Yes. Yes.
Yes, of course. Good day for all. Dear colleagues, I would like to present some results connected with the application of machine learning methods to the problem of predictive maintenance. It is a result obtained of the small scientific group of Department of Computer Mathematics of National Technical University, KPI in Kharkov. It is a brief content of my presentations, and the main ideas I would like to discuss, it is a learning models designed for classifying and predicting failures in the predictive maintenance, and the main idea which used for develop new type of predictive models is the data aggregation via regularized clustering, and some word about the general problem. Predictive maintenance is one of the most important and well-known problems, ensuring the reliability and maintainability of a dependable system. The goal of PDM system is to implement a predictive approach to maintenance with a health state of machines constantly monitoring by network sensors. So, the problem is exactly the forecasting problem, but one have some specific features connected with the applications of the general machine learning method to the specific problem of reliability forecasting. Efficiently detected whenever the industrial equipment component has deviated from its normal operated condition or predicted them a fault, will occur as a main challenge the system and rest. Official PDM methods promise to decrease the probability of our events, so of course it is very important for the practical point of view. Some words about the approaches. So there are two main approaches with PDM forecasting. First of all, it is model-based PDM, and another is data-driven. We will, of course, discuss only the second approach because the model-based PDM is based on the classical reliability analysis methods, and we will discuss the method of model bidding using the data, which give us the possibility to obtain it with a large sensor network. But in real world, it is very difficult to formulate an accurate theoretical model which could describe the process of degradation of production equipment. So the application of the data-driven PDM models is more important in the cyber-physical system, in the large computer system, and so on. Some words about the machine learning method which applied in this problem. This method may be divided into two main groups connected with the two main problems. First of it is so-called fair prediction problem based on current information about the state of the equipment. And another one, it is a prediction of some average or statistical characteristic of failure flows such as failure rate and remaining useful life. So the characteristic is well known. But the construction or the design, the model of such characteristic is not a very simple problem because the structure of this model at first is unknown a priori because usually we have no information in order to construct the very complicated dependence of such characteristics from some technological factors which describe the real equipment in the real world. The first problem is reduced to learning the classification of feature vectors equipment states in the area of non-failure operation and the area of occurrence of certain type of error. So, the first problem is a typical classification problem. And the second one, of course, it is a regression problem. But tell about it is a problem very difficult because we don't know the structure of this model a priori. State-wide, there are a lot of works connected with the application of machine learning for such a problem. It is impossible to describe it in a small presentation because in fact, every method of modern machine learning now is used for such a problem. Starting from the classical Bayesian approach, logistic regression, decision tree, classical support vector machine, and so on, and ending with the modern ones such as XBoost, CatBoost, and LightGBM. But the methods directly applies to this problem not even give us good results, because it is necessary to take into account the specific of the real technical problem which you consider. So the motivation of our work, the main difficulty of machine learning PDN application is to choose the structure of the learning model, the complexity of which must be consistent with the amount of available data. The significant, first, nonlinearity, and second, the complex structure of the desired dependencies determines the expenditure of using kernel-based learning methods. So we will consider special type of regressive models for the design of forecasting for the predictive maintenance. We will use the learning kernel-based model. Another problem related to the practical implementation of the design model is the need to restrict the complexity. That's the most important problem, the restrictive complexity of the model which we design, which determined by the number of kernel function used. Then using the big data sets of large volume, which is science failures are rare events. So the data set is very large in order to obtain the necessary information in order to construct the model. So the dimension of the model begins to grow catastrophically, even then using only support vector of kernel localizations. So the main idea we will propose, it is the aggregation of the data as the first step of the design of the learning system. And more exactly, the objective of our report, we develop at first a technique for classifying failures based on machine learning of aggregated data, uses the technique of learning of clusters in the feature space. The proposed approach is based on the preliminary clustering of data in order to reduce the dimension of the training model. This is most simply implemented by dividing the dataset into groups corresponding to the presence and absence of failures, followed by clustering. We proposed an approach based on soft clustering approach, which allows the presence in clusters of a certain proportion of objects with a different fold labels. Such approach, which can be considered as a fuzzy clusters, is very efficient for the problem we will consider. And now some words about mathematical background of our methods. First, the problem statement is classical. So we have the data set, a training data set, which consists from some vectors features. Feature set in our problem is technological characteristic of the process operation. In the target labels, it is fault or fault, so it is classical classification problem, which may be used with, for example, support vector machine approach, kernel support vector machine, and so on. But the problem, it is general problem in such applications, is the find of structure of the decision functions. When we used the decision functions as a linear combination of some so-called coordinate functions of the approximation of our decision surface, it is a problem first, find the structure of this coordinate function, and the second, to find its number. All this problem is very difficult. In fact, model theory of machine learning so directed to this problem. But we will consider some heuristic approach which gives us the possibility to obtain the training model with restricted complexity. But due to the complexity of the dependence of our characteristics from the technological factors, we will use so-called kernel-based model, which directly applied to the approximation of very complex structure with, for our consideration. Well known that kernel-based functions and functions with have the well-known properties. It's a semantic positive definite function. For example, it may be Gaussian functions, polynomial functions. So all this result is very intensive describe and learn and study in general machine learning theory. But when we use such approach in our problem, we at first consider the classical problem. It is a problem of construction of decision surface in the feature space using the so-called support vector machine approach. So the results is a decision function with dependent from the sum set of so-called support vector. It is not all the feature vector from the training data set, it's only the subset disconnected of the localization of some of the training features which lie near the decision surface. But in situation when we'll consider from the practical point of view, our data set is not only big, it is very, very large. It is in fact big data. So the cardinality of the set of support vector may be very large too. So we proposed another approach. At first step, we propose a data aggregation of our data set in order at first to construct some clusters in feature space, and the second step of model constructions to construct the learning model not on the feature characteristic of the feature vector, but on the average characteristics, and for example the center of clusters and the average characteristic of the target function of clusters. This idea is not very new. That such approach is very often used in the machine learning problems from the big data, but we propose some specific type of the data aggregation using some type of the fuzzy clusterizations or soft clusterizations. Main idea is the following. We propose approach broadest of the soft clustering, which allows the presence in clusters of a certain proportion of objects with different fault labels. To do this, we use the regularized K-means clustering techniques reduced to discrete optimization problem. This is an optimization problem which gives us the possibility to construct the clusters in the feature space, and the specific functional regularization functional include not only the loss function. As a loss function, we will use the ratio loss function as a general machine learning approaches, but we use the characteristics of the distribution of any type of our objects in our clusters. And another moment, it is not obligatory to use the center of clusters as the representatives of the aggregated data set. In this capacity, weighted generalized average may be used as this proposition, and may be used a random structure of random elements from the clusters. The randomization in these applications gives the possibility to realize the soft clusterization in the following way. And as a result, all mathematics it is impossible to demonstrate because it takes a lot of time, but only the results. It is a structure of obtaining the kernel-based learning model for the predictive maintenance using at first kernel-based approach and the first preliminary clustering. It is very easy to numerical implementation on this model because all calculation at first, in fact, it is only the inversion of the some kernel matrix. It is from the point of view of correction of this problem. It is matrix with well structured. There are no problems to find the solution in such a way. Some words about the case study. We consider synthetic data set usually used in order to test some algorithms for predictive maintenance, been proposed in well-known Irvine machine learning repository, and this dataset consists of a large amounts of the data and characteristics the typical technological or industrial process. These 6 features, it is a temperature, process, rotational, torque, tool wear, and so on, and 6,000 with connected the different failures. So And the first step, of course, in pre-processing data, we consider the statistical characteristic of data. It is very important that the data set is unbalanced, but it's only same person filed items. So it is at first necessary to do some pre-processing of this data. Most of the features are normally distributed unless one is the last feature. And covariance matrix, it is a hot map of the heat map of the covariance matrix, give us the possibility to perform the data cleaning of our data. Data aggregation, the main step. In such applications, the data aggregation has multiple purposes, namely reducing data set size to improve training and inference time and rebalancing data set to make resulting model more robust and simpler. At first step, is data clusterization in feature weight using target label as a regularization, and we add a restriction that the cluster could point only the same target value, or in general case, disbalance between different targets. It is the main practical idea to order to construct the soft clusterization. And the second step is to aggregate a cluster element and represent it with a smaller number of points. And numerical examples, it is example of classification model design. Our goal was to build fair prediction models based on process parameters using a classification approach. We use a well-known library scikit-learn. They choose SSY methods with kernel modification and use a combination of previous soft clustering with such an approach. So some words about the results. As the numerical experiments, we use two types of approaches. As a baseline, it is the standard classification with the use standard called precision performance metric. And the second variant of the experiments, we use the proposed approach of previous clusterizations. This is the results of experiments. It is typical score, typical metrics which characterize the accuracy of the classification. So it is very interesting that aggregation data, in fact, gives the results with very similar to the using of general data. So from the point of view of the accuracy of prediction, the clusterization may be used, of course. And some illustration, it is a structure of obtained non-linear decision function. In fact, it is a separation surface in the feature space. Of course, it is a projection for some features. And this visualization describes us the possibility to obtain the very good classification characteristics of the obtained decision functions, even in the situation that the data points lie in the different section of the feature space. This is only the illustration result that they give us the possibility to obtain the understanding of the practicalization of this result. This is the distance, illustrated the distance from the separating hyperspace to the data point. The result of numerical simulation showed that despite of significant reduction of the model dimension, it was our purpose, the result of data aggregation in the training stage, it retains the ability of separate the samples corresponding to the presence of absence of failures of the group located in different regions of the feature space. And the conclusions, the paper proposed an approach to the construction of kernel-known methods for the classification and predictions. The aggregation is carried out on the basis of proposed clustering methods in the feature space, and the most important is the real structure of the regularizer is proposed and investigated using numerical data. And reducing the dimension of the model not only simplifies its practical interpretation, but also contributes to the acquisition of a number of additional positive properties, such as maybe smoothing of elimination of spot oscillations and robustness with respect to measuring error. Thank you very much for your attention.
Thank you very much, Mr. Leonid. Thank you very much. Very interesting report. I hope that the very interesting and topical subject of the report interested the conference participant. Thank you very much.
Thank you.
Have a question, dear colleagues? Have a question?
Yes, I have. Can you explain me what about the number of clusters? Is this number fixed preliminary, or it depends on the dataset structure?
Of course, the problem of find the number of clusters, it is a problem of the second step of machine learning, as a find of parameters of the learning algorithm and so on. In fact, it was decided numerically using cross-validation techniques. We consider, of course, the situation when we use 2, 3, 4, and another number of clusters, and use this cross-validation, find the efficient number, which of course depended from the real structure of data set and real data. In our experiments, we obtained the possibility to use 3 clusters in our data space, but the accuracy may be improved, of course, when we consider the most complicated structure. But, of course, it may be found only using the second step of the learning, using some type of cross-validation, of course. Thank you.
Thus, I understood that it is a fitting parameter of your model.
Sorry, may I ask you to repeat, because very sound is very...
If I understood it right, that the number of cluster is a fit parameter of your model, a parameter for fitting.
You interested in the dependence of the parameters of model number of clusters?
Yes.
Yes.
Okay. We have 2 types of parameters. It is typical situation, not connected this problem. We have the parameter of the decision function, parameter of the model exactly, and we have the parameters of the algorithms. Of course, it may be a parameter of the regularization. It may be a parameter which characterizes the complexity of the decision function. It may be parameters which characterize the cluster structure of the aggregated data. And first type of parameter we find using the learning algorithm, and the second type of parameter we can find using or another data set, where data set may be divided into some groups, or using the cross-validation techniques. So at the step of the find the parameters of decision functions, it is impossible to find the hyperparameters of the algorithm as well. So it may be another problem, and they may be solved in parallel, because the final results completed all the structure, not only the decision functions, but the algorithm of the estimation.
Thank you very much.
Thank you.
Mr. Hennady, have you a question? Thank you.
Only small question. How about kernel function? What are rules for choice of kernel functions?
About the choice of kernel function. From my point of view, it is not critical, because all type of kernel may be in fact give us a possibility to obtain the high quality decision function. We use a typical radial basis function or Gauss kernel function, maybe use polynomial, but all kernel functions included some parameters. It connected with the second problem is the find of parameters, not only is the number of kernels, but its parameters. And what about the structure kernel? This form, it is not equal. Typical application to radial basis function, we use it, and I think it may be in practical application is very good.
Thank you.
Thank you.
Thank you for all.
Sorry, I have some question. No, maybe it is a general question. What challenge limitation did you encounter when implementing this method in real life settings?
Yes, we have some experience with real application of this method. I don't include it in this presentation because it may be another work. We have some possibility to consider the effectiveness of this method using for two applications. First of it will be analysis of the reliability of production system in semiconductor industry, because now it is a critical point of application, of course. And another, there are a lot of data, not only in public sources, but specific data connected with some real production. With our colleagues with work in this field from the Germany and in our countries, we have the possibility to consider the effectiveness of prediction of the failure rate in the semiconductors industry application. Another, it may be application, very important problem in the nuclear power plant reliability, but now it is in future. We only start with work, but in our real very hard situation now, I don't think that will continue now, but in future, of course, because we many years have the very effective collaboration with the Center of Nuclear Reliability of Ukraine, and I think that in future we continue this work. It is about the practical application.
Thank you very much. Thank you very much, Mr. Leonid. Dear colleagues, have a question.